All right, welcome Calculus to a review video over your related rates practice problems. I just wanted to go over a few here. I'd really pause it, help each other out next week with it. So the altitude of a triangle is increasing at that rate. So an altitude of a triangle, I would draw this triangle first. Again, pause this whenever you need to. I would draw this triangle. Guys, the altitude is just the height of a triangle, okay? So I've given you dH dt is 1. It's increasing. While the area of the triangle is increasing at a rate of 2. So I've given you dA dt is 2. All right, now area of a triangle is 1/2 base times height. So that will be the equation I'm going to take a derivative of. At what rate is the base of the triangle changing when the altitude is 10 and the area is 100? Okay, so first off, so at that time I should know what the base is. So that's why I say 100 is equal to 1/2 base times height. I think I tell you that the altitude, again, the altitude is the height. So we solve this and we get the base is 20. So I want to know at what rate is the base of the triangle changing when the base is 20. Again, that's what we're looking for. dB dt, area is 100, height's 10, and I just found out that the base is 20. All right, so I need to take the derivative of, so if you look at area is 1/2, again, sometimes my notes don't have everything there. Okay, I want to take the derivative of that, and this is going to be the product rule, because both the base and height are changing with respect to time. So dA dt is equal to, this, I'm going to call this like the first function. So derivative of the first would be 1/2 dB dt times the second function plus the first 1/2 b times the second, derivative of the second, which is dH dt. That's just the product rule right there. All right, so let's plug in what we know. We know that dA dt is 2, 1/2. I don't know what dB dt is. I know the height is 10. Plus 1/2, I do know that the base is 20, that's why I needed that, and I know dH dt is 1. So what's that going to give you? 10, that's 10. 1/2 of that, that's 5 dB dt. Move this over, you're going to get -8. So the base is actually decreasing. All right, the base is decreasing. Interesting. All right, there you go. That's it. Again, pause this. We'll talk about this when I get back. Next, I want to look at number 15 here. Gravel is being dumped from a conveyor belt at a rate of 30 cubic feet a minute, folks. That is dV dt. I should have put that right there. dV dt is 30 cubic feet per minute. It's 30. Being dumped from it at a rate, so it's getting bigger. And its coarseness is such that it forms a pile in the shape of a cone whose base diameter and height are always equal. That's pretty important. The base diameter, now, remember the diameter is is twice the radius. So basically, if the base diameter and the height are always equal, again, volume of a cone is, I'll move here in a second. For a cone, we think about that, okay? So, with respect to time, the volume is changing, the radius and the height, they are all changing. So, let's see what they give me from shape of a, how fast is the height of the pile increasing when the pile is 10 foot high? So I need to know what dH dt is, so I want to involve h. Don't really know anything, not going to be able to figure out what dr dt is, so I should really substitute something in, and we've done this before with the cone. I should substitute something in for r. So that's the radius. The radius is 1/2. See, if this whole thing is h, then this would be 1/2 h, 1/2 h. All right, so that's what the radius is. The radius is half, or h over 2, or 1/2 h. So in this formula, 1/3 pi r squared h. Instead of writing r, I'm going to write h over 2. So I skipped a little bit of work here, but when I square 2, I'm going to get 4 in the denominator times 3. That's going to give me 1/12 pi h to the third, because you have h squared times h. That's the formula I want to use. I take the derivative of that. That's dV dt is equal to, bring down this 3. That'd be 3/12, which is 1/4, pi h squared dH dt. Then just plug everything in. What I know, dv dt is 30, a quarter, pi. The rate, I'm sorry, the height is 10. I don't care about the radius. dh dt. All right, and I get that, and you can leave your answer like that. Okay, so 15 is a good one. We can talk about when I'm not there. Now, some of these I don't have totally done, but some are like basic. We don't, I mean, if you look at 20, I know I'm skipping here. We did 19 and 21. I'll go back to 21. I don't think we finished that. We did that on Friday. So the side of a square is increasing at that rate. Find the rate of increase in the perimeter. So a square is SS. So you know that ds dt is 0.2. The perimeter is 4 times that side length. Take the derivative of both. dp dt is equal to 4 ds dt. Just plug it in. All right, and that just that kind of makes sense. If all sides are getting bigger at a rate of 0.2 centimeters per second, it makes sense that the perimeter would be 4 times that. Okay, let's go back. Let's talk about this angle question. Man is moving away from a 40-meter tower at a speed of 2 meters per second. So the man is, over here. So x is getting bigger that distance. That's why dx dt is 2. All right. They told me 30. I, again, told you in class to get rid of that last sentence. That would change things a little bit, but we're just going to move it, get rid of it. Okay, so 40-meter tower, and it's always staying 40 meters. All right, so I could do the Pythagorean Theorem. I might need it later. This is 3, 4, 5, or 30, 40, 50. That distance is 50. Folks, dy dt is 0, okay? This tower's not moving, it's staying that consistently 40. So what do I know here? It wants to know the angle of elevation, which is right here, looking up. Again, it's not 1.6 meters off. I'm just gonna keep it on the ground now. So I know tangent of theta is y over x. I do know that, okay? And the derivative of tangent is pretty nice to work with because it's secant squared. So I would use tan as a nice derivative. I mean, I guess if you guys wanted to, we could. There's no reason we couldn't, say cosine of theta is 3 over 5. You take the derivative, get negative sine theta. You could say that sine theta is 4 over 5, right? Or you could say that, but then again, then you have that z. Okay, it's actually a bad idea because we don't want to figure out what z's. So that's why we don't do this. We don't want we don't have anything about dz dt. We have to use this because we're given a rate of change. Okay, so that's why we don't want to. That's why if some of you are asking why we're using tangent when I have the 3 others, that's why it has to involve x, it has to involve y. Okay, because dy dt is 0, that's easy to work with, and you have to use that rate of change for the x. So folks, we're going to have to take the derivative of this up here. Take the derivative, you get secant squared d theta dt, that should be right there, is equal to, folks, you do low d high minus high d low all over the square of what's below, x squared. So secant squared theta, folks, if secant theta from here, again, cosine is 3 over 5, so the reciprocal of that is 5 over 3. Just square this. That's how we get 25 over 9. D theta dt is equal to, folks, this right here is 0. All right, that right there is 0 because dy dt is 0. All right, so whenever I did this in class last year, I just said, hey, go from there. I'm going to write some work here. We have d theta dt, that's going to be equal to, I'm going to multiply both sides by 9 over 25. You're going to have negative 80 over 900, right? So this right here will cancel. That'll be a 100. This right here will be a negative 0.8 times 20 there would be, yep, that is a negative 0.8. No, not times 20. I'm sorry, 25. 25 is on the bottom. That's times 1. I was like, that's big. So this is, sorry, 1/25 times negative 4 over 5. Negative 4 over 25. All right, and that's going to be radians per second. Radians per second. All right, so it gets degrees multiplied by pi over 180. All right. Let's take a look. 22, folks. 22 is another type of those, and according to this, it looks very close to, and then there you go, you have pi radians. This looks very close to homework question number 16, your last homework question. So a ladder 15 feet long is leaning against a wall. The bottom of the ladder slips away from the wall at a speed of 1.5 feet per second. Slips away from the wall, so that means that's actually the x, so that's dx dt. It's moving. If it slips away, it's moving over. How fast is the angle between the top of the ladder and the wall changing when the angle is? So that is up here. How fast is the angle between the top of the wall and the ladder? That is up there. When the angle is pi 6 radians. Okay? So that's the wall. That doesn't look good there. So what do I want? I know dx dt is 1.5 right here. Okay. Now, I don't really know anything about how fast this is going down, right? I don't have anything about how fast it's moving down, and I'm not asked that, so I'm probably not going to use it. Using this wouldn't be great. I know that dz dt is going to be 0. So if I go here, I can say that sine of theta is opposites. Besides, I've got, I know this is pi 6. Sine of theta is opposite over adjacent. I got to use that 15. So sine of theta is x over 15. I'm going to take the derivative of that. That's what that means. So cosine theta, d theta dt, is equal to 1 over 15 dx dt. That's another way to write x over 15, 1 over 15. Okay, so cosine of theta, that's just cosine of pi 6, right? Because we're evaluating it when that angle is pi 6. Cosine of pi 6 is root 3 over 2. D theta dt, folks, dx dt is 1.5. So that's actually, if you multiply those two, it's going to give you a tenth. Here we'd multiply both sides by 2 over root 3. You get that. Simplify it. It's that radians per second. All right, we'll talk more about those. I'll give you some homework help when I'm back. A conical water tank with vertex down. I love these. You're going to see these definitely sometime again. Big time on quiz and tests. If the water flows out of the tank, folks, that's finally, we have a volume, a derivative that is negative. Okay, it's flowing out. Water's flowing out. dv dt is a negative 16. Notice how you are giving, this has nothing to do with dr dt, not that it's 0, it's just you don't have any of that info. You're not given that info, so you need to get r out of there. If r is 8 and h is 18, here's what we can do. We can say h over r is 18 over 8. Do some cross multiplying. We'll get r is equal to 4/9 of h. And if you just think 18 versus 8, 8 is 4/9 of 18. So r is 4/9 h. So when I use the formula, volume is 1/3 pi r squared h. Instead of writing r squared, I'm going to write 4 over 9 h. I'm going to square that. Okay. H squared times h is h to the third. We got pi. 4 squared is 16. 1 times that is 16. 9 squared is 81, multiplied by 3. Take the derivative. You get that, 48 over 2, 43. Pi h squared dh dt. Obviously, dv dt is on the left side. That is 48 over 2, 43 is 16 over 81. So I'm just going to clean this up, honestly. Divide, multiply, divide. All right, go from there. dh dt is going to be a negative number. Okay, I just didn't get the answer there. All right, so 24, that looks like it's homework question number 6, evidently. So it could have been like the other one we did. All right, a balloon leaves the ground 400 feet away from an observer. Okay, there's an observer. There's the balloon. It's leaving 450 feet and rises vertically at that rate per minute. All right. So maybe the observer's here. All right, yeah, the observer's line of sight, I'm sorry. So there's the balloon, it's going up, here's the observer. At what is the rate, what is the angle of inclination, angle of incline? The observer's line of sight increasing at the instant when it is exactly, I think what do I get rid of, 330? Yeah, I don't know why I scratched that out. Well, I think to make it easier, it would be that, yeah, so I think we want 450 there. We want 450 there. In fact, we're gonna go back and look, because if I have that, then tangent of theta be a little bit nicer number. All right, so we'll come back, we'll talk about that one when I am back. Let's see, 25. Again, I plan on making another video there. We'll check to make sure we want those numbers. A train starting at 10 a.m. travels west at 50 miles per hour, while another starting at 11:30 from the same, so it's right here, it's traveling west, sorry, right here traveling west. And another starting at 11:30 from the same point travels north at 70, okay, northwest. Now, how fast are they separated at 2 p.m.? So that means the one that was going west has traveled for 4 hours. All right, dy dt was 50, it's growing, it's 250. Now the one that started at 11:30 had only been going for 2.5 hours. 2.5 times 70 is 175, and it's dz dt, dx dt, it's getting bigger, is 70. Pythagorean Theorem, this squared plus this squared, you're gonna get that. Obviously dz dt is getting bigger. All right, that's what we need. So take the derivative of this. We talked about 2x, 2y, 2z, you can divide everything by 2, plug everything in we know, and then just, multiply, add, and divide. We'll get that. And then for right now, I'm gonna do 26. Again, I'll try to make another video to help you out. Would you have time when I get back? Gas is escaping a balloon, so dv dt is negative, and it's negative 5.5. How fast is the surface area shrinking? Okay. I'm going to use this formula. Take the derivative. dv dt is this. Okay, plug in what I know. The radius is 30. Let's find dr dt. Okay, you're going to get 3,600. You're going to divide both sides by that pi. That's how I got that. Negative 1 over 900 pi. Surface area is that. dsa over dt, or ds dt, is equal to 8 pi r dr dt. I'm looking for this. Put in 30. Put in negative 1 over 900 pi. The pi's cancel. We get that. All right. I will give you 27 since it's looking at us. And I'm going to go over and see what else I want to talk about there. And another video. dv dt, folks, is negative 22. It is leaking. Derivative is negative. If the radius is 8 and the height is 65, find the rate at which the level of oil is changing. Well, folks, we need dh dt. Dr dt is always 0, so I don't have to fuss with that. Again, in the United States show this way too. You could use the product rule. Do derivative of the first times the second plus the first times derivative of the second. And if dr dt is 0, well, it's just really going to always be this. So I can just keep not fuss with r squared and just take the derivative with h. That's the only thing that's changing on the other side. So that is what we can do. Given volume is pi r squared height, just take the derivative of that. dv dt is equal to pi r squared dh dt. All right, and that's what we get. Attach a unit to it. All right, folks, this is the first video. Another one will be coming your way shortly.